Hello, everyone. Thank you for waiting. I'm sorry about the intro. I believe I misconfigured the intro song and the elevator music stopped. So lessons for next time. Thank you all for showing up. I believe we do have quite a few of you in chat already. Today is about clean architecture with event modeling, or event modeling with clean architecture. This is going to be our, let's say, last thematically primary or sort of clean architecture adjacent topic for, let's say, this month. Next week is the 20th anniversary of domain-driven design, as it's Tuesday. I believe it will be 20 years since the book got released. So from next week onwards, I will be making the topics more domain-driven design focused. Similar concept, domain-driven design with TDD, domain-driven design with event modeling. We might actually reiterate on some of these concepts, and I'm sure there's space for domain-driven design with clean architecture, or even talking about something specific, like an overlap of domain-driven design and clean architecture. Where does this terminology overlap in a way that is meaningfully complementary, and where does it overlap and it's accidental, and a lot of beginners especially struggle with it. Hey, Sanam, it's always great to see you in chat. So the agenda for today, I did actually write it down this time so we don't ad-lib it too much. The agenda for today is, let's see, I'm going to present to you a little bit of a event modeling cheat sheet. The event modeling community has moved, and I'll be reviewing this course, and then we can have a little bit of discussion. There will be a recap of this episode on Tuesday next week. So I am slowly and surely introducing a lot more structure into these calls. So that means that on every Tuesday, there will be an announcement of that week's agenda and a recap of the last week. So it's sort of halfway through the week, halfway through the work week in between two episodes. So you can sort of either catch up with the last one or prepare for the next one. I got a lot of positive feedback that you would appreciate that. Okay, let me close the stuff I don't need, because I'm using Chrome, and oh my god, am I memory starved. No, I'm not memory starved. I want my memory to be used so things work faster. But sometimes that means that there's too many things that want to work fast at the same time. Okay, see what I did there? Let me just check the due diligence of do all of my comments, do all of your comments, make it to me in yes. This is also on YouTube, yes, and I did miss. I see. So I missed those chat items where, if you type them in, where I wasn't streaming yet. I see. Okay, so that's unfortunate. We are learning. So, do we have any questions before we start? Clean architecture and event modeling are using event modeling. I'm aware that there's a slight delay. I will give this a little bit of a pause, and if you have a question, I'll address it before we start. To those obvious questions, yes, we are recording. Yes, this is on YouTube, and yes, this is on. And yes, this is on. Thank you, Balaji. Love that guitar. Thank you. My daughters have started crawling, so crawling to the extent that they'll sometimes come in and just start pushing and against the guitar, which I love. I love just being surprised and being delighted by their presence. But it does mean that I have to manually position it sort of on my stage. We have some questions already. Let me check. So I would like to. So Saddam, you posted two things, and I would just want to make sure I got them in the right order. Let's see. Are they in the right order? Yes. So what are the best ways to develop a clean architecture across the team? What are your thoughts about this? For instance, when developing an e-commerce application, any type of application with a team of members, If we have some backend, some front-end developers, how should you divide the features among the team members? This could include segments like the domain, application logic, infrastructure, API integration, testing, and client-side component. Ooh, so that it's a lot of concepts in there. I don't think we're gonna address all of them at the same time. But let me put your other question up there first. I love the way Milan presented his course. He began with the domain layer, followed by the application layer, and then the infrastructure, and finally the presentation layer. He updated each layer accordingly whenever necessary. This approach is suitable for solo developers. However, if you or your team are working together, I would like to know how you manage everything. You share an overview. Okay. So it's not event modeling specific, but it is clean architecture specific. I actually need to think about this for a moment. So there's definitely differences if, let's say, since you mentioned backend and frontend, there are definitely differences in the way that you integrate if your backend system and your frontend system are on different stacks, right? So if you're on a React frontend with a C# backend, then you'll have a little bit more friction regarding clean architecture as you would with something like the T3 stack or Next.js or Nuxt.js, right? Where the two stacks are in both stacks are in TypeScript, and you might even have code reuse. Same thing with C#. If the entire front, back, and sort of middleware are all in C#, you might be able to leverage some lower level libraries, some lower level project solutions into each other, but not fully as the frameworks start clashing with each other. So for the organizations, you said what are the best ways to develop? I mean, it depends. The best way for your team is what is best for your team. Like, so you should sit down with your team and discuss like where do you struggle the most, and specifically what is painful, and then do the thing that is painful more often to see whether it can be improved. That's my sort of shortest version of the answer. I know you won't be super happy with it on all nuances, but definitely involve everybody in the project when you have conversations about the domain. This is where domain-driven design really comes in. I'm really happy to sort of tackle this question a little bit for a little bit more detail next week for the domain-driven design themes. So for this to be successful, your team sort of needs to agree what the domain is, right? So this is where perhaps microservices come in well, is because usually, people usually ask me, how large should a microservice project be? And it's the wrong way of going about it. It's not the code that's micro, it's the team that is micro, right? So you have a vertically integrated stack where the amount of people necessary to manage it, to own it, front to back, security, infrastructure, DevOps, data architecture, domain, understanding the business concept, understanding the modeling, and understanding the functionality it has, the functionality it doesn't have, the non-functional requirements. That it's a microservice because all of that can be maintained, and then CI/CD and managed and deployed, and dependencies managed can be managed by one or two people, or two or three people. Right? It's the team that is micro, not the service itself, right? So in order for this to be successful, the team needs to agree what the domain of the service is, like what does it do and what will it definitely never do, right? So you already have an automatic answer for what you will never put into it. If you're working on a monolith instead, or you two monoliths, maybe your backend is a monolith and your frontend is a monolith, then you also need to understand, okay, there are likely several contexts hiding in these two monoliths. And with the front end and back end specifically, some concepts, like some context, might be connected to a very high degree of coupling. Not all coupling is the same. So when you're working in a monolith, Saddam, this is still regarding your question. When you're working in a monolith like that, what you're looking for is not to reduce coupling by going into a microservice approach. That's the common fallacy that people think they should be doing. What you're looking for instead is increase the quality of the coupling, right? So such a project will have a lot of bad coupling, a lot of coupling that is accidental, that is, well, I need to put this here because I'm compiling it there, and then I sort of need this to be existing in the file structure before this exists, and the binaries have a certain order. That's all infrastructure concern. That infrastructure concern should be captured in each project's infrastructure layer so that you can slowly clean the architecture and sort of distill all the infrastructure concerns away from the application, and then even take one step further, and then you distill all that away from the domain. How do you introduce this in a team? Well, the team needs to be on the same page, right? So if you have a front-end team and a back-end team, maybe the front-end architect does some things differently than the back-end architect. If you constantly have clashes in communication, well, maybe it's not two projects, maybe it's one project, and they should then the leadership structure does not match the intended architecture of the project. You can shape in this by conducting a reverse Conway maneuver. The Conway's law says that your infrastructure, your architecture of your code, your design of your code will always match your communication structure within the team. So the way the team is set up. If you're not happy with how the architecture is set up, well, change the communication structures first, so that if you know that this always happens, ask yourself, how does your team need to be restructured so you create the architecture that you want. That is the reverse Conway maneuver. And some people argue that it's reversing the other way around, that you're setting up the architecture so it will force you to communicate differently. But I think that's the clumsier approach. So yeah, regarding orders of layers, I think you should be working on all layers all the time. So this is essentially vertical slice architecture. So add a little feature. That feature should have all the necessary domain concerns, all the necessary application concerns, and all the necessary infrastructure level concerns, and then decide. Be pragmatic, as Milan says. How much, not how much coupling do you need, but how do you improve the quality of the coupling? Some things will have high coupling because they naturally have high cohesion together. There are some features that are supposed to change together. Those things should be coupled together. So then you can decide, okay, well, how do I describe this as one unit, or maybe I need the application model and the main model together, and then you have a subcateness test. And we'll talk about a lot of that today on the event modeling side of things. So there's that. I could go on, Saddam, and I will next episode. And now I'm going to continue with the other questions, and then we go to today's agenda. Balaji, please let me know if I pronounced that correctly. When can we go with the clean architecture? Is it bound to any use case? Can we customize this theory of clean architecture for API-related projects? I think the book is a good starting point, and especially with what you're seeing in a lot of sort of tech influencers like myself, either on YouTube or on Substack or on LinkedIn. What I would recommend is that clean architecture is useful when you're trying to increase the quality of your coupling, or when you're increasing the quality of the cohesion of each layer, and you're already wanting to use a layered architecture. And a layered architecture can be anything. It can just be a multi-tier architecture concept. It can be service-oriented architecture. It can be clean architecture, hexagonal. The onion architecture is a very popular one. These are all similar concerns. Even the model view controller pattern that people misconstrued it as a pattern, that's actually an architecture. And model view controller, you will notice that it follows model application infrastructure. It's just that the presentation layer and this is back in the sort of Ruby on Rails and PHP days, where the view, the presentation layer was actually an infrastructure concern, because you're deploying compiled payloads through the web onto the client's browser, right? So it became this sort of complicated mess of, if it appears differently in every single browser, and there's no guarantee that they even have JavaScript turned on. This was back in the early 2000s. Does it even make sense to call my view part of my application, or is it, living on somebody else's phone? But we don't have those problems anymore. So often nowadays, the presentation layer is separate from infrastructure concerns, but it is still an infrastructure style concern, which is where the use cases come in. I would say definitely, if you're not working on a new project, if you're working on a existing project that doesn't follow clean architecture, try to figure out where the layers are. There will definitely be a lot of application level application layer classes that have inappropriately coupled domain and infrastructure level concerns. Try to identify what those are and just refactor it. I always say that clean architecture is not something you do, as a process. Clean architecture is an output of refactoring and refactoring everything, on a system level, like repackaging things, moving namespaces, thinking about it on the non-functional requirements of actually having clean architecture, essentially. So the order of the dependencies of what depends on what other things, that you're refactoring that as well. It's like, hey, should this package be dependent on that package? That's clean architecture, and you get there by refactoring it. Let me know if there's more detail that I missed there. I usually do a recap on these, and then I figure out I missed. I even didn't get the question, and then I re-answer it next week on Tuesday, in case that's the case. Joseph Barriga, what performance parameters does event modeling bring with clean architecture? Performance, perhaps none, but it'll definitely impact the performance of your team. And I will keep this favorited and starred. I want to return to this question when we start looking at Bobby's course. I will answer it, so I will not forget. Okay, but consider a scenario if an API is getting a fetching data from other APIs, can we still use this architecture? Yes, you can, but it's the sort of, if you're asking me if you should, you probably shouldn't. Like, there should be an intrinsic, let's say, quality drive to just refactor continuously. And once you're stuck refactoring in the point where everything is so clean, but there are certain areas that are depending on each other incorrectly, and you don't know how to start refactoring them because the dependencies don't make sense, or the smallest coupled unit that you can end up as a result of refactoring, you end up with like a local minimum in the overall sort of where you can go without actually starting to break things further apart. So the refactoring might actually become invasive. So you're actually factoring, not just you're actually creating new functionality, but you just have to hard break things apart. When you get to the point where you think you got to the smallest unit and it's still pretty big, I think that's the area where you need to introduce clean architecture into your refactoring concern, where it's no longer just craftsmanship and just the structure of the code, but we actually need to refactor the structure of the project. That's, I think, when the best scenario is to introduce clean architecture, if you have such a need. Definitely, if you're doing an MVP and you'll throw this code away, or if your business is not profitable, or if you're on a hobby project, or there's no team, you're just solo, the need or even the business benefits or any kind of benefits for clean architecture go out the window pretty fast. The whole point of clean architecture is that working with a team is a little bit simpler, because you have a sort of unwritten rules about, or even written rules about what goes where, so that when somebody is working on them, that it becomes easier to sort of grasp without having a full understanding of the overall system. And usually, if they're subcatenous, which is an event modeling term that I like to return to later, subcatenous projects that have subcatenous UIs and subcatenous tests are super easy to sort of onboard somebody to, because usually the UI is just abstracted at just the right level, so that they won't waste a lot of time sort of debugging or trying to mock tests or mock UIs or mock infrastructure concerns where you're using some kind of DTO framework or even entity framework where you're sort of generating DTOs from other concerns, but then it's really intercoupled with everything, and then you can't really boot your application or even your tests without having the IDE generate some complex code, right? So it's sort of outside the scope of a single developer. That's usually an anti-pattern where it's like, okay, the architecture went too far being married with the framework, then that project can benefit from clean architecture. Because what clean architecture says is that you should be very peculiar about what you marry yourself to. The quality of the coupling. Are you coupled to your frameworks? Are you coupled to your ORM? Are you coupled to your infrastructure level concerns? Are you coupled to your UI? Or do you want to keep the door open and be able to have multiple different types of UIs, like a mobile UI, a web UI? Is that the same API, or the mobile front end have a mobile backend? So is those types of concerns where clean architecture comes in handy. So you start separating out those layers. So in case you need to have, and if this is a backend project and you need to have combinatorially complex configurations, that those are available to you when you need them, or at least that you have the knowledge, but how to even refactor them to such a state. Okay, I think that's everything. And then we'll return to Joseph in a moment. And I'm just refreshing here because I'm sure that something will go wrong today, right? Present. Wait, what did not work last time? Okay, so now I'm in the actual share screen, and I need to share what? How do I share screen? Okay, so I can only share a tab, and I need to click this so the audio is shared. Good. Okay. Appreciate your constant. Okay. Thank you for the question, Balaji. I'm just checking the other tab real quick if I missed any questions. It seems we're synced. Oh my god, the timeline of these comments is quite... Yes, okay. Yeah, we're up to date. Awesome. So I'm just going to run this, and I have some notes here about what we'll be looking at. And specifically, I'm already cheating. I wanted to give you the cheat sheet first. Let's go with the cheat sheet. The cheat sheet is this. This is the cheat sheet. What's really important for us, if you're beginning with event modeling, and this is now tying into Joseph's question, the idea behind event modeling is that it is, let's say, an iteration on agile concepts. So it is trying to sort of get the end-to-end toolkit of working in an agile manner, but without making it about management. Most of the frameworks that I saw, Scrum or even Scrumfall or Waterfall or some weird combination of we do Scrum our own way, or we do Scrum but we didn't really read the handbook, is this idea that the process itself is so complex that you end up having different levels of documentation for the same thing. An example of this might be, you create a story. Well, the story is documentation. The story is a process. But maybe only the PO and the project manager are writing into that, and then everybody else is commenting into that, right? And then you might have a C4 diagram or a technical spec or an architecture diagram, and then only the engineers write into that, and maybe the project owner comments on it. And then there's some design, some Figma documents, and only the designers write, right? So it creates these sort of information silos where specialists own that area, and then you don't really, I don't really move designs around, and the designer doesn't move my architecture diagrams around. That's a problem, because we should have, it should be collaborative. We should be enabled to sort of get different people into the same room, into the same meeting, and discuss, hey, if you move that button from this screen to that screen, I need to change my backend architecture. That is often the case. Or if you move, this functionality from this screen to this screen, I need to change how the mobile application is structured. This is a very natural downstream consequence. But most of our documentation is not handled that way. And what event modeling is sort of aiming to do is trying to get the right level of not having technical jargon on the screen, right? So UML is too far. UML is like coding, but without the IDE. You're just coding with diagrams and with like squares and boxes. That's too far. That's too far in the sort of technical detail area. And then you have wireframes in UX design and sort of lo-fi skeletons. That's too far in that area. That there isn't enough technical jargon. There aren't any contexts. There aren't any downstream dependencies. There's no differentiation of like, is this data? It's a UI element. What here is persisted? What data do we save? What does the user do? Right? So it's a bit wishy-washy. Event modeling is sort of an iteration. Think of this process as an iteration. We're distilling 40 years of agile practices, and now this is our current iteration of what other processes can we just get rid of, including, your Jira for tracking tickets, including Figma for design, if you would like to, and just have one simple document where you put all of the little pieces. The developers put in the specs, DBAs put in the database, the infrastructure level concerns, your PO and a UX designer, talk about functionality, and you just, in the concerns of a web, you just talk about the patterns of how does the data flow evolve to this application. What are the consequences? What is an action? Is it user triggered or is it automation triggered? Is it triggered by somebody hovering their screen? Is it triggered by somebody scrolling, like the TikTok feed? Or is it triggered by some concrete action? Or is it triggered by automation or time passing? Usually people hate planning, designing models where something occurs because time has passed. It's like, where should I put it? Like midnight at zero, like here. And event modeling is a great way that really captures that, where everybody can give input. So regarding the cheat sheet of what's on the screen, it's relatively simple. Think of it like there's a natural flow. These are the building blocks in the left side here. So white is UI triggers or user interface of some kind. Usually these are wireframes on your board. From white, in order to show the UI or trigger the automation, you read from a projection, the green box. So green goes to white. White produces blue. So blue are the things that happen. So the side effects of the blue things is that something in our infrastructure layer changes. We will store something, we'll persist something, maybe in just a state, facts, events, or think about it as if I shut down the server, what should still be there when I boot it up, right? So what got saved to disk? Think of persistence as this. Everything is in memory, and then when I shut down the server hibernates, and something has to go to disk. What goes to disk? What goes to disk in a way that you will recreate the memory from that disk rather than having the entire memory dumped and just recreate it continuously. And then the events, when you have them, they update the green boxes, right? So white goes to blue, blue goes to orange, orange goes to green, green goes to white. And this is the flow, right? And the whole idea behind event modeling is that you put the entire flow onto the screen so that you see where the gaps are. So that you see something like, oh, the user will go to this screen, and then they will go to that screen, and then the data will magically appear there. Somebody might say, well, hold on. When they clicked on that screen, if only their mere presence creates something, well, there's a hidden command that gets triggered somehow that the user doesn't automatically trigger. What does that? What is that? Well, maybe a visit recorded or user visited. Well, hang on. Okay, well then, what gets updated by the time the user goes to that other screen? Right. So what event modeling allows you to do is plan your architecture in such a way that you are aware of sort of the dependencies of your modules. That's why I like to use event modeling with clean architecture, because clean architecture is about the directionality of what should depend on what, in what order, how do the packages make sense. And event modeling does that for the project layer. It's like, if this is the timeline of the project, maybe I want to start on the right side to start with the UI layer and the subcateness UI. Well, okay. Well, if the UI depends on that thing, what is the minimum you need to develop on the backend side to show that other thing, right? So it's this idea of, if I want to demo this layer, what is the minimum I need to develop on the other layers to show it, right? So you're traversing this dependency graph, but on the entire project scope, and this is called vertical slices. So one good example of this, if I go back, yes, what a good example of this is on the event model. You will notice that there are some vertical slices of green, blue, orange. So one triplet, or tuple, a quintuple of green, blue, orange, white is usually called a vertical slice. And that is usually with continuous delivery able to be deployed and isolated, so that you can just fake everything adjacent to it and just deploy that. And that's usually where the performance boost comes. So Joseph asked what performance benefits does event modeling bring with clean architecture? Well, it allows you to plan your project so that you determine what the vertical slices of your architecture will be, so that if you have like a big domain, a big application layer, and a bunch of infrastructural concerns, that you sort of, in the same sense as vertical slice architecture, like you model by just diagramming the life cycle of the project as you would with estimations or with Jira, like you just create a roadmap for the project of following how the data evolves, you get vertical slices. And you can, in clean architecture, you can just imagine the pie, and you're just filling up the slices of the pie. Then you can decide, well, this slice is the closest to the UI that the user wants to demo, right? So then you can put them together, and then in order for it to function, it needs this data, and in order for that to function, it needs this data, right? So you can just sort of follow and put your project together in a way that you can follow progress visually, or that you can demo often. Maybe you don't want to demo and you just want the hard backend stuff to be done first, right? So it gives the non-technical people some oversight on how the architecture will evolve. And in what order it will evolve. That is usually the most important part. When people ask you for estimations and a roadmap, they want to know in which order things will happen. Like what will happen first, and then what will happen next. And people crave certainty. We are creatures of habit. We want to be in the habit of knowing, okay, we will start here, and then we'll go there, and then we will have a meeting next week, and hopefully by then we'll know whether the project is on point and we can demo something, or we will have better questions. Right, so people are planning and doing event modeling to avoid stagnation, to avoid this idea of, I've been busting my head on some problem for 3 weeks now, there's no progress, and everybody's stressed out. Okay, so that's the cheat sheet. So remember, white goes to blue, blue goes to orange, orange updates green, green is necessary to show white. Okay, we'll practice that. Now to the course. So I just want to mention this video here because I really like. I won't do the whole thing. I will put the link in the chat. The link in the chat, and you can check it out yourself. So let's go with Bobby. We have 22 minutes.
The first objective in event modeling is to capture the narrative of your business process as distinct events. Doing so will create the context for the rest of the process the same way a script sets the context when producing a film. We'll begin by defining what an event is, and then we'll proceed to brainstorm and then sequence these events into a plausible story. So what do we mean by business event? A business event is the record of an important business occurrence, decision, or outcome. At this early stage of the modeling process, let's forget about software and systems and instead think about record keeping with paper, snail mail, etc.
Nice.
We can ask ourselves, what set of outcomes would I have to write down in order to keep track of this business process if I was using paper and pencil? These events have a name or a type, as well as a data payload, which we'll talk about more in just a bit.
Awesome.
The sequence or stream of all such business events comprise the causal narrative of a bounded context or a business domain. For example, in our autonomous vehicle,
you can see how we're already mixing domain-driven design, event modeling. There will be some mention of event sourcing later on, and if you follow closely, you will notice that once we get to the infrastructure, to the implementation parts in the later steps, I will jump over some of these. You will notice that you immediately start seeing clean architecture concerns as well. It's like, oh, this is purely a pure function. This is a business model. This is a business domain concern, right? So it's the domain layer. Oh, this is purely application specific. It's something to do with the session of a user of some kind. Oh, that's completely event processing specific. That's application layer, right? So, and then you might have all the infrastructure layer concerns hidden from the event model itself, because you want the engineers to figure out the best infrastructure to just make this, I want this domain to have this domain. I want to have this application. And then I don't want the non-technical people and the planning people to be concerned too much with infrastructure level concerns. Ideally, I just want to outsource that to maybe some platform team, a DevOps team, or maybe the team has already set up a project in such a way that this is trivial. And sometimes it isn't.
Vehicle ride-sharing app Autonomo, we might have an event representing the decision to match a requested ride with a specific vehicle. The event name or type might be ride scheduled, and the data payload could include the ride ID, the rider's user ID, the vehicle's identification number, the pickup and drop-off locations, and the pickup time. Using this example to guide our thinking leads us to the conclusion that events must be denormalized and data covering, meaning all data necessary to understand the business process is contained within the events themselves. There's one exception to this rule for large blobs of binary data like images, sounds, or videos that we don't want bloating our event storage. In this case, we can use the claim check pattern where we store the blobs in a separate location from our event store, and then include the URI for retrieving the blob in the event data rather than the blob itself. All other data should be included inline within the event. Now that we've settled on a definition of business event, let's capture some in our event model. The first step is to brainstorm our events. The goal at this step is broad participation, and there are no wrong answers at this stage. Invite the participants to write verb phrases in the past tense on orange stickies, and get as many on the board as possible in a fixed period, say 15 minutes. Out of order, probably some duplicates and wrong answers, but it's a great start. Our next task will be to sequence these events into a plausible narrative, add in missing events, and eliminate duplicates and non-events.
So this is equivalent to domain-driven design event storming up until this stage. All right. So what we're doing essentially is we're creating a storyboard, and there's a separate video on that as well. It's like building a storyboard, where we're trying to follow the flow of data. Right. So again, the orange boxes are the things that get persisted to the hard drive, that are durable, that are stored. Think of it as we are planning the application CI/CD pipeline plus the evolution of the domain model as an accountant would. Like, we are storing everything in an immutable ledger, and we're trying to figure out what are those immutable facts that happen that shouldn't be modified. And we want them presented left to right, so they represent their age on a particular timeline, right? So when the user logged in or started a process, that's the left side of the timeline. And when they got closer to the final part of the UI that has the important checkout button, or what is this ride sharing here, where they arrived at their destination and are about to leave a review, that's on the right side, that's on the far right of the timeline, right? So because what benefits does it have? Well, the benefit of this is that you can come in to this project and say, okay, I understand it, and the team right now is trying to build a prototype for the UI, so everybody is on the right side, and they're faking everything that's missing on the left side. Right? We want to be able to have that kind of conversation.
The participants should be able to roughly sequence the events pretty quickly, perhaps in 10 minutes or less. Then, it is often useful to invite one participant to walk backward through the rough sequence to check the plausibility of the story with the whole group. Often at this step, the group will identify and add some missing events. In our first event brainstorming step, getting active and broad participation is more important than getting precisely correct events. However, as we sequence and filter our events, it is important to distinguish what is not an event so we can replace or remove them. Business events are not, usually, low-level UI or system events, like a user mouse click or the arrival of a TCP packet. These are usually too low-level and fine-grained to describe an important business app.
This is already this concept of it's not supposed to be about the UI. It's only supposed to capture business domain events. This is already separating out the low-level stuff, which is infrastructure in the clean architecture lingo, from the domain level concerns. Right? Even clicking a button, that might be the equivalent of an application or infrastructure layer concern, depending on where the button is and how the button behaves. Right? So this step is already distilling the conversation that everybody in the team, everybody has a little awareness, and there are some gaps and there are some overlaps in understanding of the business, and everybody's sort of brain dumping. And of that brain dump, you are documenting essentially the domain layer. So if you're doing a clean architecture, the clean architecture project, these initial orange boxes, once you define them, will define your domain layer to you. They will define, okay, this is everything our domain is, and then clicking buttons and having that UI element refresh there, and then having this automation, that is no longer the domain layer. Right? So this immediate step handles the hardest part of a project. It's like what goes into that box and what doesn't.
Outcome. Of course, that is unless these are your business domain. For example, if you are building a user analytics or security app, then you might need to record user clicks or TCP packet arrival as a part of that domain. In other domains, low-level system events might combine or roll up into business events. Another common non-event is a query, view, or notification of current state. We'll almost always capture these as read models. One exception might be a business-driven snapshot event that captures a moment in time, such as a monthly closing of the books in banking.
You will notice when he started talking about read models and write models, we're already getting into the area of CQRS, and he specifically is event modeling a system that will be event sourced, which is the most natural way of building systems nowadays, especially if you're building a data product, a data B2B SaaS product, like most startups are, even if you're in the AI space or ML space or crypto space. Please just use event modeling and event sourcing. Make your life easier. Crypto is naturally event sourced. There's no reason why you wouldn't event model that concept. And if you have done a crypto project in the past, you will notice that modeling systems are not having an event model, not having a timeline hierarchy of how things follow A, B, C is really hard, especially if you're writing things like smart contracts, or you want to know that you didn't miss any gaps, any levels of detail, anything that might go wrong, or will I need to go back to this contract and maybe have it self-destruct in some weird contingency scenario very far in the future. These kinds of models that have a timeline component, are very useful for that. And usually UML and sequence diagrams lack that, because they just have the order, not even just the timeline, because the timeline helps us put it into the context of adjacent aggregate hierarchies, adjacent application flows. Maybe you have a backend application that has state and a frontend application that has state. And a typical example of backend application state and frontend application state would be a one-time token authentication system, right? Where you have like two systems with state and they are time sensitive and you have to synchronize them. Like those are very hard to model in like a typical spec and then have some designs for it. But it's very trivial to model with event modeling, because the timeline is the key component to the actual data flow of the system.
Finally, most requests from users to change the state of the system are in fact commands and not events, especially if we can immediately decide what to do about that request.
So that's a blue box.
So as we step through the model to check the narrative, we can also remove non-events or replace them with a placeholder green read model sticky or a blue command sticky. Here's our rideshare example after sequencing and filtering our events. Notice how this sequence of events reads like a plausible story and doesn't involve any low-level software or systems concerns. We've completed step 1 of our event modeling process by capturing the business narrative as a sequence of events.
Okay, let's jump to step 2. I'm just going to skim over this real quick.
Great user experience can rarely be added to a system after it's built. Medium that somewhat resembles another tried and true visual design medium, the storyboard of a film. The events that we discovered and sequenced along the bottom of our diagram in the previous step represented the major plot points of the script. In this step, we'll place interfaces consisting of graphical mockups of our UIs along the top of our diagram above their corresponding events, and these interfaces represent the frames containing concept scene visuals in a storyboard. Finally, we'll represent the characters in our film by identifying the various audiences who will use our system and organize our interfaces into horizontal lanes representing each audience. In contrast to commands, events, and read models, which are represented simply as a colored sticky note with the name written on it, interfaces are much more nuanced and labor-intensive. For that reason, it's important to select simple and familiar tools to produce these interface mockups. The goal for selecting a tool is to maximize participant productivity. Sometimes low-fidelity tools are the best for getting started quickly. In physical in-person workshops, printer paper and markers work really well. For digital workshops, you could choose a simple drawing tool. Other times, the team has already produced high-fidelity prototypes in a design tool like Figma, PenPot, InVision, Sketch, or similar. Or perhaps they have screenshots.
So you will notice that sometimes your business counterparts are creating detail in the area that overlaps or is complementary to yours. So if you have like a project manager that is very non-technical, they might start building detail where they are comfortable. So you might receive production-ready designs. You might receive production-ready mockups. You might receive sort of native iPhone and Android level UX wireframes. So whatever they're comfortable with, they might give you that level of detail. And then if you want, you can put them on the board, and you can already start projecting the different UI states on the board. So rather than having a wireframe and they go from A to B, you put them on the event model in the right timeline, and then you track back and forth from the event model. Well, when the user clicks this, that's a blue box. So it will create this orange box at the bottom. So you're trying to figure out in order for all these events to happen naturally, that's your domain, that's all of the features you need to create a feature-complete applications, how can the user access it? Do they need to install Postman and call the API themselves? Or is there a natural UI sequence to how these events happen? Or maybe just the passage of time. Sometimes it is the passage of time. Sometimes it's two applications, right? Like in this example where there's a rider app and a driver app, and then they have to collaborate. So, there's a lot of sagas and syncing in the data flow where they have to sort of collaborate, and they have timeouts, and you have race conditions, and then all the messy infrastructure level concerns really come to the surface. I just want to show you there's an exercise to show you this regarding the
So far,
recording.
we've considered the business narrative of events that we'll need to record on the back end, and we've envisioned how our users experience the system via the interfaces we expose on the front end. Now we'll turn to the task.
Notice what we just watched, domain and presentation layer, right? So recall, clean architecture, domain layer in the inside, application layer outside, and the last layer, the outside layer, is a thin layer of infrastructure layer concerns, and then presentation. Sometimes the use cases are inside, outside the application, depending on which version you're looking at, and the presentation might be an adapter or just a common pattern on the infrastructure level concern, or tightly coupled to the application through some use case. These can differ. I write about this a lot on the Crafting Tech Team's newsletter. So if you wanna check that out, there's a domain-driven. I've created a clean architecture little category on the Substack page, so you can find it a lot more easily if you want to read into that. Or please subscribe to the newsletter if you're an enthusiast and haven't already. So I just wanted to mention, right, that he is starting the project by the extremes. He wants to understand the domain layer and the presentation layer, because those have the most impact on what it is we're building, and then we're connecting the dots.
Of connecting these two worlds via an API of commands and read models. So what are commands and read models? Simply put, a read model is a view into the state of a system at a specific point in time, and a command is a user's expression of intent to change the current state of the system. There is a system design principle called Command Query Responsibility Segregation, commonly abbreviated as CQRS, which states that state-changing operations, commands, should take a separate path through the system from operations that merely retrieve or perceive the state of the system, queries or read models. Mm-hmm. Many event-based systems using Kafka naturally adopt this separation. For example, with streams recording state changes and tables servicing reads in many Kafka streams and KSQLDB applications. Event modeling makes this distinction explicit and visual by specifying separate model components for commands and read models. A real-life example of CQRS might be found in a sporting event. Many people, fans, officials, photographers, commentators, coaches, and players, can perceive what's happening in the game by watching it unfold play by play, which is like reading the event log of our system, or by looking at the scoreboard, which is like the read model of our system's state. However, only a few of those people, mainly the players and perhaps coaches and officials, can actually take actions to try and affect the course of the game. We call these actions that might affect the system commands. By adopting the separation of concerns between commands and read models, our goal is to make the system simple and intuitive to our users so they can get their jobs done. To that end, we aim to inform our users about system state in the most convenient, helpful, and timely way possible. Rather than exposing a whole database schema or resource hierarchy to our users, we reduce cognitive load by only showing them the summarized information relevant to their next action. Many systems that are designed database first expose complex, fine-grained CRUD, or create, read, update, and delete operations to their users, and place the burden of avoiding illegal or nonsensical system states on these users' expertise. In contrast, systems designed through event modeling expose commands, which are composite actions natural to the business and designed to achieve a specific set of business outcomes as specified by events.
So the important part here is that the commands themselves have enough information to carry out what the user is doing, but usually the UI knows just enough about what the command will need to not have to perform any complex joins that are time sensitive. You probably noticed this when people are doing CQRS. One of the most common questions is, well, yeah, but if I'm just sending the IDs, then the command, the aggregator or the command processor will need to query different read models to dereference all the IDs to even get the current state to rehydrate itself to even validate the command. The idea here is that you want to give as much detail as possible in the command itself from the UI layer, especially if the data being transmitted is not sensitive. Any questions here so far, by the way? I will close this off in like 5 minutes. I'm just wanting to give you a little primer on what's going on with event modeling. I just want to jump to this video real quick because there's an important concept here that is really highlights how event modeling in CQRS works in a way that is not very complicated. It's very easy to understand, even if you're doing clean architecture, right? So it's these arrows, for example, are a very good example of there's a ride. The green thing is kept up to date to show your UI. When the user makes a decision, it generates a blue thing at some point in the future, right? So it's a little bit to the right. And then that immediately validates and creates an orange box. And then that orange box updates again the ride and makes the driver available, etc. Right? So it's the timeline. The data flow is going left to right on the bottom, and the subcatenous sort of backend to front end to backend flow is going top to bottom. So this is very easy when you have these sort of axes on a project diagram, because you can decide, oh, actually, that last part, when we get to the checkout and we set reviews, that's what we want to demo next. We just take this vertical slice, and everything before that will just mock. And you'll know exactly what you need to mock, because the only thing you need to mock in order for you to be conducting this test is to know in what state those green boxes need to be in order for you to show the UI, to fake the UI with a mocked green box. Or if you want to write a test for something backend heavy, well, in order for you to mock it, you need to be able to say, my system is in this state by having events or projections. When that's the AAA, arrange, act, assert pattern for writing unit tests. When I'm in this state, when this blue box happens, I want the orange box to be the output. That is a very natural way of how testing happens. And this course does go into a lot of detail on that. There are details about functional programming later on. You even have a little exercise in how to create your event model. And later on, you'll even get into some F# concepts about the decide pattern, right? So describing your event models as a pure function. Let's see. Okay, just buying myself a little bit more time with my next call. Okay, somebody just announced they'll be late. See how the universe provides everybody with ample opportunity to get things done. So what I wanted to highlight here is that the more detail you'll step into, the more you'll be tempted to bring the infrastructure level concerns and the application level concerns into the domain layer to have like an end-to-end test kind of scenario. But that makes it very clumsy. You create this sort of melted cheese stuck to a radio type architecture where everything is really hard to tackle. And I think that ties into Joseph's and Balaji's questions earlier on. What I would want to highlight here, not from the course per se, but from the intention of the course, when you're talking about domain functions, especially, and there's some decider patterns that you can explore here. And I believe in the introduction, there's also where was it? Where did I find it? The course conclusion. Yeah. So there's a functional event sourcing decider. This is a concept where you can write your domain logic, your invariants. So you basically pull everything from the infrastructure level concerns, you pull it from the database into memory, and then you describe how your domain works just as state machines, as pure functions. And this is an F# example. I don't know a lot of F#, but you can check out the sort of theory behind it to learn more about how to express your domain as pure functions, because you've probably never done that before. So if you want to try something new, this is definitely a good start. What I also want to show you is this has landed, and we're going to put it into the chat. This has landed recently on the event modeling community chat, and this is Adam Dimitruk creating a setup, a template conversation with ChatGPT on. He has described what event modeling is to ChatGPT, and then you can have a conversation with it where you describe a system domain, and you basically have ChatGPT create an event model for you. Like, it'll decide what the green, orange, blue boxes are based on a conversation, right? And this is a great example of how to leverage AI in today's world for building a spec and a project diagram, perhaps even vertical slices. It won't be perfect, but it might serve as a very good first draft, especially if your domain is complex, because it has a lot of domain detail or a lot of parallel domain concerns. We saw the two parallel domains with the rider and the driver in the sort of Uber clone example on Bobby's course. But it might be, there might be 7 parallel tracks. There might be payment involved, and logistics, and then shipment, and then fulfillment, and then packaging, and getting taxes correct. And there might be so many parallel concerns that the complexity just comes from the number of domain layers or domain adjacent layers. The application level concerns are actually so complex due to other infrastructure, third-party services being integrated, that something like this might help you create a very good first draft, from which you can then dump into a little Miro board and just use that as version 1 that you then present on screen. And then using that, people put the post-it notes on top of it. So you refine it and correct it rather than having to do everything from scratch. That's one update. The other update is that the event modeling community is moving from Slack to Discord. So if you go to eventmodeling.org/resources/Discord, you'll be able to find the link to join the Discord community and talk to Adam Dimitruk, discuss this course. I think Bobby, the course author that we just looked at, is on the Discord as well. You can ask them questions. You can, you asked me what's the best way to get into clean architecture. Joseph asked, what performance benefits does event modeling bring with clean architecture? You can discuss these things, maybe discuss this video on the Slack. I would encourage you to join. And yeah, I think that's everything that I wanted to talk about today. Are there any questions? And I will now do the thing and refresh this thing, because I sometimes I miss chat messages. I'm very sorry. We are fixing this. We are gradually learning. I'm getting better at this. I did miss one. No, I don't have it. Thank you, Saddam, for staying with us till the end. I did miss a question. Now, I can't highlight it because I don't see it in my chat sidebar thing. But I did get it on LinkedIn, and one of the questions was by Dylan. I'm sorry, I will butcher your last name if I try to pronounce it. So Dylan asked, but I lost the question. I just saw a notification. I just want the full question. What are the benefits of event modeling over event storming? And then he has a follow-up question. Do we event model only the complicated parts of the system? Great question. I'm just going to give it a few minutes to to address, and that will be our last question today. Sorry, I can't highlight it because it didn't pop up in my doodly-doo. Again, this will have to be debugged some other time. So question number 1, is it the same as event storming? Question number 2, do we only event model the complicated parts of the system? I'd say I would say the idea behind this is that event storming is the domain-driven design workshop. So you would talk to your business experts to shape a language, and event modeling is more of a project management concern, where you're trying to shape the system in a way that is easy to understand how the vertical slices of each project will make sense to put on the roadmap, to put on the timeline, in what order are you implementing them, right? So event modeling is much more pragmatic than event storming. Event storming is trying to distill the perfect language to really capture what the business is about, get the terminology there. Event modeling is all about building, right? So it's more like craft oriented. Regarding should you only model on the complicated subsystems parts of your system, I would say if you're event modeling, event model everything, but event model everything in such a simple level of detail that you're not wasting time modeling all the time. It's just that you have enough detail on the page so that you capture everything. Because what you want to do with event modeling is you want to get everything from left to right in the timeline to see if there's gaps. Because if you can't connect the dots from the left side of the timeline to the right side of the timeline, somebody missed something. And it's a very good visual tool to see, oh, we didn't discuss that important thing. Like there's a gap here. I don't know how the data comes from point C to point E. Like we missed something. We forgot some event. Maybe it's time-based. Maybe there's a delay, right? So that's what you want to really discover while you're event modeling. So that also means that you should be modeling your simple parts of the system as well. That's all for today. Thank you all for showing up. I hope that's satisfactory, Dylan. I'm very sorry for not being able to highlight your questions. If there's any questions that I've missed, I will be recapping them on Tuesday on the newsletter post. And then I'll see you next week for the anniversary of domain-driven design. And we'll probably be tackling a little bit of clean architecture, but mostly domain-driven design next week on the call. So thank you all for showing up. Really appreciate it for you that you're here, that you set an intention to be here live with me. I will now give you back to the space music, and I'll see you next week. I'll leave the stream on for a little while longer, and I'll see you next time.